All right, so my hope was that I was going to do the whiteboard problem with you, but I'm not there. And I know you don't want to look at me doing problems for 15 minutes, so I'm just going to zip it through. Once again, if you need like to go over it again, just pause the video, try it, and then see where you get there, because I will go pretty fast. Are you ready? Okay, let's go. Let's recall how to write each logarithm as an exponential. You're going to set that equal to x. This is not going to be on your test, but this is the very basic understanding of it, so you got to know it. How do you convert again? Base 3, exponent x equal to 20. What is the base of when you don't see it? 10, common base. 10 to the x power is equal to 1000. What's the base here for the ln natural log? E to the x power is equal to 40 is how you do it. By the way, that x, I can just say that's going to be about 2 point something, right? Because 3 cubed is 27, so this is 2 point something something. I'm just estimating it without a calculator. What about here? That is 3. 10 cubed is 1000. So if you ever get your answer like log of 1000, you should not write your final answer as log of 1000. You should write your answer as a 3, because it's the integer that you can find what it is. Okay, this one obviously I can find what the answer is. You need a calculator. All right, now evaluate them. So feel free to convert to the exponential form and then go from there. So 3 to the x power is equal to 1 over 27. Got flipped, negative exponent. 3 cubed. Answer is negative 3. All right, what about here? 25 to the x power is equal to 1/5. Well, this is tricky. All right, got flipped, so I know it's a negative. What do you have to do to 25 to get to 5? You have to square root it, right? Square root of 25 is 5. How do you write square root as an exponent? Square root is the half as an exponent. That becomes a denominator. So this is like a tricky. It's not only a negative exponent, but also a fraction exponent. All right, what about here? I'm going to set that equal to x, convert to the exponential form. Base is 5, exponent x is equal to 5, square root of 5. I remember doing this on your notes. You have to combine those as a 1, so it's the 5 to the first power times 5 to the square root is half power, right? Well, what do you do when you're multiplying with the same base? You add your exponent. So what's 1 plus half? 1.5. So x is 1.5 or 3/2, however you want to write it. Which two integers is the between? 3 cubed is 27. Oh, do I have to do this? I think I just did that in the previous. 3 cubed is 30. Excuse me, 3 to the x power is 30. 3 cubed is 27. 3 to the 4th power is 81. So it's going to be between 3 and 4. Set that equal to x. What's the base? 10. 10 to the x power is equal to 200. Well, I know that 10 squared is 100. 10 cubed is 1000. So it's between those two. That means x must be between 2 and 3. Particularly close to 2. Okay? All right. These are all the properties of the logarithm. We should not get confused. Don't memorize it as a multiply added. Like, actually think about it. When you multiply the arguments, you add the logarithm because you're adding exponents. Okay? These you're pretty familiar with it. Power property, the exponent can be dropped in the front of the log, and vice versa. The coefficient can go as a piggyback right on top of the exponent of the argument. And same thing. What about here? Log base b of b to the x power is just going to be x, because log base b of b is 1, so you can cancel out. B to the log base b of x power, you can cancel b and log b out and get with the x by itself. All right. Let's expand it. All of them have x. Well, my argument has x and y and square root of z in it. So it's going to be natural log of x squared plus natural log of y cubed plus natural log of square root of z. First of all, I can just split that like that, right? Exponent of the argument can be dropped in the front. So 2 natural log of x plus 3 natural log of y plus, what about here? That's a half. So half natural log of z. All right. Log of 8th root of x. Can I write as a x to the 1/8 power? Yeah. Okay. Y is to the 7th power in the denominator, so it's going to be minus log of y to the 7th power. drop it in the front, 1/8 log of x minus 7 log of y is how you expand it. Now, condensing it is backwards. So whenever you see the coefficient that goes as an exponent, so it'll be log of, I'm going to do it all at once, 6 squared, 9 to the half power. Why did I put it at the bottom? Because it's the negative. And then 5 goes on the top. And you're just going to multiply all together. 6 squared is 36 times 5. Ooh. Oops. 36 times 5. 108. And square root of 9 is what? 3. Which is log of, I can still reduce it, 36. I think that's it. Alright, what about here? Piggyback, so it'll be natural log of 2 to the 4th power divided by 16 to the 3/4 power. Ooh, this is very interesting. Okay, so natural log of 2 to the 4th power is 16. 16 to the 3/4 power is same as 4th root of 16 cubed. Right, denominator becomes nth root. 4th root of 16 is 2. 2 cubed is 8. 8. 16 divided by 8 is 2. Natural log of 2 is the final answer. Ooh, that one was hard, wasn't it? Alright, now let's do how to solve logarithm equation. That one looks like a bell work, so let's do this one. I see logs on the one side. We're going to condense it because both of them have log base 6. So log base 6 up. Both are positive in the front, so I'm going to multiply x times x plus 5 is equal to 2. Okay? All right, I have a single logarithm. Convert to the exponential form. Base is 6. Exponent is 2. Equal to x squared plus 5x. All right? What is 6 squared? That's 36. So 36 is equal to x squared plus 5x. All right. What is this? This is quadratic equation. How do you solve quadratic equation? Set it equal to 0. Factor. Set its factor equal to 0 and solve it. Do you remember doing this in the class? Oh, yeah. So x squared plus 5x minus 36 is equal to 0. A, C, B chart. Negative 36. B is 5. What is it? What is it? Help me. I can't think. 12 and 3 doesn't work. 2, 2, 3, 3. So 2, 2, 12. 9 and 4. 9 and 4. Wow, that took a while. 9 and 4. 9 and negative 4. I can actually take a shortcut because a is 1. So x plus 9, x minus 4 is equal to 0. I get negative 9 and 4, or 4 technically, as an answer. All right. I got to check the answer since it's a logarithm equation. How do you check it? Plug it in. Oops. Whoa. Negative 9. Negative 9. Can I have a negative argument? Nope. Hello, aren't you working? Negative 9 is not going to work. And what about 4? 4, that works. 4 plus 5, that's a 9, that works. So only answer for this question will be just 4 there. Okay, now let's look at 4.4. This is exponential equation. 5 to the 2x power is equal to 20. It is already in the exponential form, so what are you going to do? Sometimes when we have an easy problem, we just get stuck, right? All right, what's the base here? 5. So what you're going to do here is you're going to take log base 5 on both sides. Log base 5. 5 to the 20 to the x power equal to log base 5 of 20. Okay, so take log base 5 on both sides. Why are we doing it? So that you can just cancel that log base 5 of 5 out. So you're left with 2x is equal to this, which is log of 20 divided by log of 5. Then you're just going to divide everything by 2. It's going to be your answer. For exponential equation, you don't have to check your answer since you can have a negative answer. Okay. All right. Now for the rest of the class, you're going to work on your study guide question. Remember, answer key is up on your Google Classroom. You might have some question about the last free response. Obviously, on the test, you don't have the calculator with you, so you won't be able to find the answer or anything like that. But you should still be able to know what that means. What does the input mean? What does the output mean in the context of the problem? Okay? All right. Good luck. Bye.